Two people are running straight towards each other. At a certain distance, they are 57.5 meters apart. The first person moving at 3 and constant acceleration 0.1, and the other person moving at 2 with constant acceleration of 0.05. How long does it take them to meet? Now, where most got really mixed up on is somebody's got mixed up at the very beginning of the question. Your maths and algebra are quite advanced. There's no disputing that. But your idea of what the technique should be is where the dispute is, okay? So this is person A and person B. And the deal is that they run a certain distance each. So for example, person A runs S1. Person B runs S2. So what is S1 plus S2? Gonna be, your test is there somewhere. What is S1 plus S2? Anybody? 57.5, because they're 57.5 away from each other to begin with. Okay? There you go. We're going to UVAS both systems for A and B. UVAST, UVAST, and 3.1 S is just S1. Are the times the same? Is it the same time frame? Did you both start at the same time? Yeah, so it's a common t value in both sets. 0.05. And U equals 2. Did anybody do an approach with did anybody do a relative velocity approach with one set of data? Very smart. So if you were to do that method, what you could do is pretend that one of them is stationary. Okay? If you're running towards somebody at 3 and they're running towards you at 2, it's the equivalent of somebody being stationary and the other person running 5. Do you get what I'm saying? So the relative velocity approach would be that you just say U is equal to 5. V you don't care about. Now the acceleration, because both accelerations are coming towards each other, you add them. You get 0.15. S and T. Now the glorious thing about this one is that because you're effectively keeping one of them stationary, the other one has to do all the distance. So the distance is 57.5. And if you were to just do UT plus V squared, S equals UT plus half AT squared, would do the job, would it? Yeah, and you get the answer right out. So the Y on the left is quicker, but I've seen people, smart lads, make mistakes using that method, okay? So if you are to use it, make sure you can do it properly, okay? We'll stick with the more conventional approach on the right, okay? And you'll find you'll end up with the same equation anyway, okay? So what we're going to do is we're going to do S1 plus S2 equals 57.5. So UT plus a half AT squared for both of them. So you're going to get 3T plus a half of 0.1, which is 0.05 T squared, plus 2T. What's that then? Plus half of that, which is 0.0, half of 0.05 is 0.25 T squared equals 57.5. And then we can see that it ends up to be the same as U's approach in a second, because you're going to get 5T and then plus 0.75 T squared equals 57.5. Is that cool with you guys? Alright. If it's alright with you, I'll skip the quadratic equation stage of the question. As I said before, it's the concepts, not the maths, which is the issue. What's the two T values? Just 10. Was it just one answer, or was the second answer negative? Yeah, the other answer was negative. We'll keep doing that. The other answer was negative, so you don't have to worry about it. Okay, so the answer was 10. 10 seconds, right? That should have got you 10 marks. Okay, or some form of attempt to 10. Find the speed when the two of them meet. Well, that's not so bad, because we have V equals U plus AT for both of them. So the first one was going at a speed of 3, has an acceleration of 0.1, and we know it's traveling for 10 seconds. This results in a speed of 4 meters per second, while the other one is going. The other one was going 2, was it? 2 plus 0.05 acceleration times 10, and this was also worth another 10 marks. So you could have got the wrong answer in part 1, but if you carry your answer over to part 2 and do it correctly, you could still end up getting 10 on the second section. Okay. Alright guys, so that was 20 marks, and now we're heading into the 30 marker part B. Okay, so part B is somewhere in here. Got this. This is tricky. A cyclist who is traveling at constant speed of 8 meters per second on a straight road observes a car 50 meters ahead. So, for argument's sake, bike and C to represent the car. Okay, so what do we have there? We have 50 meters ahead, no bother. Now, the car is accelerating from rest, so U equals 0 and A equals A. The bike, its U value is 8, its V value is 8, A value is 0. He just catches up with the car. So, what my question is, if the car was to travel 100 meters, how far would the cyclist have to travel to just catch the car? If the car traveled 100 meters, how far would the cyclist have to travel to catch that car? 150. If the cyclist was to travel 200, how far would if the car was to travel 200, how far would the cyclist have to go? 250. So we have a generalized equation here where the distance of the distance of the bicycle is the distance of the car plus 50. And if you don't have that down, you're going nowhere. Okay, so there's no other way of doing it. So some of you went wrong right at the start, and then once I know that's happened, I'm just looking for any equations or any attack marks I can give you that your solution and this solution will have in common. Okay, but at that stage you're out of the game unless you have that nailed down. Okay, so let's go for this. We're going to go for SB. So we're going to use S equals UT plus half AT squared for both of them. And what we should get is just 8T for the bike because it has no acceleration. And then SC for the car. V we don't know. S is just SC. And T is T, so it's going to be 0 T, so then it's going to be a half AT squared. So, alright. Now, what to do next? Add them both together. Sorry, not add them both together. It's 8T SB equals SC plus 50. The half AT squared plus 50. At this point, I'm going to stop because I've encountered my first problem. What's the problem? 2 variables, 1 equation. This isn't going to work out for me until I have another equation to use. Okay? So we've used S equals UT plus a half AT squared, no bother. I think we'll go for V equals U plus AT maybe. Now, will it work or will it not work? If I use the data for the bicycle, what will happen? Once I use the data for the bicycle, I'll just end up with 8 equals 8 because there's no acceleration. So that's no use to me. I'll go for the car now and see what the car can come up. There's a piece of information I didn't put into my UVAS yet. Does anybody know what it is? If you just catch something, what does that mean? Yes.
Final velocity of the car 8.
The final velocity of the car is 8 because you just reached the bike just reaches the car, and then at that point the car starts to go faster than the bike. So we actually know that v is 8. Okay, so that's our problem solved. Then v equals 0 plus at, isn't it? Now I have a direct substitute for at. I can say that at equals 8. I'm going to say is multiply both sides by 2. 16t equals 8t multiplied by t. See how I did that in a second. Plus 100. Once to the 80, lads, turns into. Sure, it turns into 8t. Then 16t take away 8t is 8t equals 100. And t equals 12.5, is it? Or did I make a mistake? Huh? It is 12.5. I should just can't find it. Who got 12.5? Ah, grand. Right. Is that the goal of our question, or is it something else? Acceleration. I think what, do you know what it was in the test? I think I just went straight for A. If you get what I'm saying, I just subbed out T and went straight for A. But yeah, we can fix that up really quickly. 12.5 A equals 8. And then A equals 8 divided by 12.5. And what's 8 divided by 12.5? I'm hoping it's 0.64. Is it 0.64? Alright. Grant, there's my acceleration. I believe my acceleration gets me 15 marks. So all of that is 15 marks, okay? Now I'm on to the next part. How near would the cyclist get to the car if he can only manage 6 meters per second? So, essentially this is a brand new question. So, a lot of my old information is gone. Okay? Now, the first question I might ask you is, can I use phi equals 6 in this question? How near would the cyclist get to the car if he can only manage 6 meters per second? So, we change the bike to what, guys? U is 6 and B is 6. And then, can I use the car phi equals 6? I can. Because anything after phi equals 6, the car is then expanding its gap on the bike. And that's not the closest you can get. Can I use SB equals SC plus 50? Is that a viable option in this question? Why not? Yeah, it doesn't catch it. Yeah, it doesn't catch it. So that's no longer good enough to get me the answer, okay? So I'm reevaluating what I'm doing. Okay, there's still a 50-meter head start. That's not okay. All right. I know what's my acceleration from the last question? 0.64. So this is actually quite easy now. This is a very basic question now. Here's what we're going to do. We're going to find the time taken, or even the distance. You have two routes. You can do phi equals u plus at, and you can find out the t value, and then you can throw that into s equals ut plus a half at squared, and then you can find the distance the car travels. Does anybody have a more direct route? What's the only equation we didn't really use there? P squared equals u squared plus 2as. That will find me the s value in one equation instead of 2. So, being the lazy person I am, I'm going to choose to do that instead. Let's write in win. Okay. P squared is 36, u squared is 0, 2as is going to be 2 times 6.4, which is 1.28. S 36 divided by 1.28. This is S of the car, so SC. So distance covered by car is, did anybody get, oh sorry, 28.125? Let me check that for me. Alright? Alright. Next thing I'm going to do is going to do the distance of the bike. Turns out, I'm going to need the t value anyway, haven't I? Remember I was talking about phi equals u plus at earlier? I'm going to need that t value anyway, so it wasn't really the shortcut I was hoping for. But I'm going to have to do phi equals u plus at. And I'm just going to go here and I'm going to say, alright, 6 equals 0 plus 0.64 times t. I'm going to divide 6 by 0.64. 9.375 is the time. I needed that time over here actually, because p squared equals u squared plus 2as wouldn't have worked. So now I have to do s equals ut plus a half at squared. And once I do that, it has no acceleration, so this is s equals 6 times 9.375. S equals 6 times that to get me 56.25. Now, remember the picture, okay? Bike, car, 50 meters. Car then moves another 28.125. There goes the car. Now you're at 78.125. Okay? And then your bike travels a distance of, what's it, 56.25. So this answer is going to be, you're going to have to add your you're going to have to add your 50. So the car has gone this far away from the bike. And we haven't taken into consideration what the bike traveled yet. So that's, the car would have that if the bike didn't move at all. But now the bike has moved and it's 56.25. And you get an answer of 21.875 meters for how far your car is ahead of your bike. Good. All right. We'll keep going. 7 minutes. Okay, let's move on. The next question was. Next question was this one here. Now, all right. This is known as an interval question, and in the interval questions, what we have is interval question, lads. And what this interval question is it starts at P. P is the start, and Q is the finish. Okay. Now, there's a rule we've always set for these. What does anybody know the general rule for doing all these types of questions? You always do start. You always use the start to any sector, or the start to the finish. I'd never pick R to Q. Do you get what I'm saying? I'd pick P to R and P to Q. I'd never, ever, ever, ever pick R to Q. Doesn't work, right? So the minute you do that, I know it's damage limitation time. How many marks can I give you? Because you're not getting there. I know straight away you're not getting there. Okay. So here's what we're going to do. We're going to do P to R, or sorry, P to Q, and we're going to UVAS P to Q. And we're going to UVAS P to R. Okay. So does it tell us at initial speed? Oh, sorry. Sorry guys, I'm wrong. I read it wrong. That was an interval question. Just two particles, is there? Red particle and blue particle. Sorry, that was my fault. Red particle and blue particle. They're thrown upwards and they actually meet at R. Okay? So the red and blue particle meet at R. Okay? That was an interval question. Now, yeah, let's UVAS this. Now, the direction doesn't matter. Okay? So an example is, if I'm traveling this way, there I am, and that's my home. Oh, sorry, that's my, I don't know, friend, right? And if I travel, I don't know, 20 meters, and they travel 80 meters, we know that it makes up the distance in between us. So it's my distance plus their distance. You don't have to take negatives into consideration here. All what it is two distances coming together. It doesn't matter that they're in the opposite direction. Okay? So essentially, this distance here, we call this x. This distance is y. We say that they meet after 2 seconds. Speed to meet. All right. Let's just throw down a few. Let's just UVAS each one and see what we come up with. Okay. I'm going to UVAS the red one, which we'll call A, and it's UVAST. Okay. Do we know how fast it's thrown up? Call it U. Do we know, is it stationary when they collide? Is there any evidence to say it's stationary when they collide? No, leave V alone. Okay. A, what's the acceleration here? Minus gravity, because you're decelerating. Your S value, suppose you can call it Y. And your T value, you have a choice. You want it to be T plus 2 or T minus 2? I generally like pluses. Are they launched at the same time? Oh, my bad. Jeez, I'm reading everything wrong here. They meet after 2 seconds. It's not one of them is thrown after 2 seconds. They're meeting after 2 seconds. So that's a common T value. Okay. Now we're going to go for B, which is in blue. Okay, is it dropped? So what happens if it's dropped? Lads, if the wording says dropped, what does that mean? Huh? U is 0. B we don't know. Oh, but we do know something. What's this say? P values equal each other. So then in that case we have a common V. Okay. What happens when you drop it? Is it a plus G or a minus G? Plus G. Our S value, for argument's sake, just call it X. And our T value is T. Okay. So, where to go after all this? Okay. I suppose we could try V equals U plus AT. Yeah. V equals U plus AT for both of them. Let's find out. So, velocity of A is going to be U plus AT. What's U plus AT in this case? And we know. Now, I also want to prove that my Y equals 3x. Does that make sense? The goal of my question is Y equals 3x. Because I said Y is P to R and X is Q to R. Okay? What do you say? I'm going to keep it in terms of G, but that's... oh, and they meet after 2 seconds. There was my other piece of information that I didn't put in yet. I haven't put in that they're both 2 seconds. Okay? So U equal VA equals U minus G times 2. Or whatever you can put it into your... you know, like that. So U minus 2G. No bother. What about VB? VB, anybody? 0 plus 2G. So that's VB equals 2G. What can we say about VA and VB? Equal each other. So U minus 2G equals 2G. U therefore equals 4g, or in decimals, it's, was it in decimals? 39.2 ms squared. Right, great. So I can fill out my U value now. U is 4g, or 39.2 if you want to go that way. What's the V value in both cases? That's the V value. Is 2g, which is 19.6. And then your G values, if you want to go that way, is 9.8 and minus 9.8 and plus 9.8. Okay. I think we're at the stage where we're going to find the S values now, aren't we? Your choice, ut plus half at squared, or phi squared equals u squared plus 2as, whichever one you want. I generally use s equals ut, so it's going to be 39.2 times 2 minus a half 9.8 u squared. What you get for the distance traveled by a, or the y value? Anybody got it? Okay. And the x value is also ut plus a half at squared. And what you get there? And what can we say then? Therefore, y equals 3x. 58.8 equals 3 times 19.6. How many people got full marks for that? Full marks being 20. Alright, I'll see you up there. I think I'll answer the question in the test. Now, alright, move on. Next one is, oh, this is a good one. 2009. Okay. Now let's go through the language really slowly, so I don't jump to conclusions. Train accelerates uniformly from rest. U equals 0. V equals V. A equals F. S equals I don't know. Alright. And then there's a speed with uniform acceleration. Then it decelerates uniform to rest with a deceleration of 2f meters per second. Total distance traveled is d. Draw a speed distance diagram. Is there any indication that it travels at constant velocity? Is there any indication that there's a flat top? So you have two choices. Choice A or choice B. Which one is it? It's A, because it doesn't say it travels at constant velocity. It says it does it, then it decelerates. Now, next question. Which one's shorter, the way up or the way down? The way down has a more rapid deceleration. Okay? So, there's a trick we learned, and what way did I do this one? Yeah, this one could be done so many different ways. Okay, so there's lots of different routes to getting this answer. So, you want to label V. That can be T1 and T2. What's the rule when you have twice the acceleration? Twice the acceleration is half the time. The ratio of acceleration to deceleration is the same ratio as T1 is to T2, the opposite times. So acceleration to deceleration is the ratio of 1 is to 2. So essentially, what we're saying here is that T1 is twice T2. And for argument's sake, let's just say T2 equals T. So what can we say about the whole thing then? The first part is 2T, and the second part is t. And the total time, 3. Okay, so that's our speed. Do you know how much you get for this? Do you know how much you get for the speed distance graph? 10. 10 out of 30. 10 out of 30 or something like that. So, lovely question. You can put in tan alpha and beta if you want to do acceleration that way. Imagine there's no big deal there. Now, average speed of the train for the whole journey is d over root 3. Find the value of f. What's the formula for average speed? Total distance over total time. And in this case, it'd be d over, probably d over 3t, wouldn't it? Average speed equals d over 3t. Okay? Which is grand. Now, can anybody get me the d value? The d value is the area of the entire graph. Anybody had to get me the d value? Base times height, half base times height. So what's the length of my base? 3t. So d equals a half 3t. And what's the perpendicular height? B. So my d value is 3 phi t over 2. Good with that? Alrighty. So that's the d value. Okay. Now, let's have a look at what to do next. Okay. We're still very, we're nowhere near finding the value of f. Have I even done an equation with f in it yet? I haven't even used f yet. So that to me means use an equation that has f in it somehow. Okay. So let's start off with tan alpha. What is tan alpha? Anybody remember this trick? Tan alpha is it's the acceleration. Okay. Tan beta would be the magnitude of the deceleration. So tan alpha is your velocity divided by your time taken. Okay. So tan alpha is phi over t2. And what is phi over t2? What is the acceleration? The acceleration is f. Okay? So now we have a direct substitute for v, because we might not want v in our answer. So we can now say phi equals 2f t. Is that all right with you guys? Now, the next thing we have is, we have a formula for average speed, don't we? Would you agree that's the formula for average speed? Total distance over total time. But we also know that that equals d, root d over 3, or, yeah, d over 3. We know that these two formulas equal each other. Okay? So we know that d over 3t is exactly the same as d over 3. We don't like square roots either. So what are we going to do next? I'm going to square both sides. I'm going to get d squared over 9t squared equals d over 3. One of those d's can disappear now, can't it? So we can have d over 9t squared equals, what's it, 1/3, is it? Okay. What'd be a good choice next to do? Is there any f's in my equation? And I don't want d either for that matter. So what I'm thinking about doing is, I'm thinking about what happens if I was to combine this equation here with this equation here. What could I effectively do there? I could get rid of v, so I can say that d equals 3 times 2ft times t over 2. Alright? So direct substitution for d would be what? What would be direct substitution for d then? I think it's 3ft squared. And that works out brilliantly. Because now I can go down here and say that d is 3ft squared over 9t squared equals 1/3. The t squareds cancel. Gone. And then I have 3f over 9 equals 1/3. Then I'm going to get 9f equals 9. And finally f equals 1. Who got f equals 1? Alright, that's the question that broke most people. I think that's probably that one. That's the hardest linear one, in my opinion. This one here. Very abstract. The real skill there was realizing you had to eliminate the d and you had to eliminate the v. And somehow you had to bring f into the equation. That's where the skill was. Okay. Move on. Right, good old projectiles. Now, okay. So, horizontal ground. And it has a speed of 21. Now, unfortunately, those of you that didn't do really well in this section, you were making mistakes on your equations. You were mixing up sine and cos a lot. And unfortunately, when you do that right at the beginning, there's not much I can do with temp marks wise once the mistake is made right at the beginning. Okay? So you have to be really, really careful at the beginning of the question. Okay, so 21 is the hypotenuse. The angle is alpha. This means the adjacent is 21 cos alpha, and the opposite is 21 sine alpha. Then you go for Vx. Vx is in the x direction. That means it's 21 cos alpha. Gravity acts straight down. This means there's no acceleration in the Vx direction. Nextly, Vy, which is 21 sine alpha. Take away gt. And now you have your Sx, which is 21 t cos alpha, and Sy equals 21t sine alpha minus a half gt squared. If you made a mistake before here, you're in trouble. Always check. Just double check everything before you continue. Okay, we're good. Now, what's our information? Do we know if it's on the way up or the way down when it hits the target? Would you agree both is possible? Like I could send a high and it could hit the target on the way down, or I could hit the target on the way up. That's why there's two answers. Okay, that's why there's two possible values of tan alpha. Nextly, okay. Next thing is this is the point 3010. And what does the point 3010 mean? At the same time, Sx equals 30 when Sy equals 10. They both have the same time for both of that to happen. Okay, so that's no big deal. So what we're going to do next? Okay, let's just go for the Sx equation. So what's the Sx equation, guys? 30 equals 21t cos alpha, and then t on its own is 30 divided by 21 cos alpha, which is 10 over 7 cos alpha. You always have a choice in these questions. The blue equation is linear, while the yellow equation is quadratic. I'd rather get t using a linear equation than solve a minus b using a quadratic. There's massive difference between the difficulty in both routes. So in this case, I chose the linear first. I got t on its own. Now that I have t on its own, I can insert it into the quadratic. Now, sy is 10 when the t value is the same as when sx equals 30. So 21 times 10 7 cos alpha minus a half gt squared, so a half 9.8 times 10 over alpha. Oh god, did I forget my sine alpha? I did. Alright, so here's where all the fun begins. 10 equals 30. Sine alpha over cos alpha is tan alpha. Minus 4.9 times 10 is 49. 49. What did I do there? T over 2. Oh. Squared. Sorry, I made a mistake there. T squared. So it's going to be a half of 9.8, 4.9. And I'm going to multiply that by 10 over 7 squared. And 10. 10 over cos squared alpha. Now, here's the real money, where the real money's made. What do I do with this part here? Idea what I do here. Minus 10 over 1 over cos squared a. And what's 1 over cos squared a? There's a rule in your tables on page 14 of your log tables. And it's how you do this question. 1 over cos squared a is also known as sec squared a. And sec squared a is the equivalent to 1 plus tan squared a. You would have been asked to do this in your trigonometry chapter of chapter 8, I think. So you would have done this already. So that's what you're doing there. Okay. So what am I exchanging this whole thing for then? What am I exchanging that yellow blob there for, so to speak? It's going to be 30 tan A alpha. And it's going to be minus 10 into 1 plus tan squared A. You're going to rearrange this whole system. And when you rearrange this whole system, you'll get the following quadratic equation. You get tan squared A minus 3 tan A plus 2 equals 0. When you solve your two values of tan A using the quadratic formula, it's essentially x squared plus 3x plus 2. Same thing. Okay? You're going to get tan A equals 1 and tan alpha equals 2. And that's your two answers. So that's 15 marks to get there. Who got that far for tan A and tan 2? Okay, so there's a couple of you. Okay. Now, part 2 is find the two possible times taken to strike the target. So we actually have the value here. We know that the time taken is 10 over 7 cos alpha. Now the only issue here is that we don't know what cos alpha is. So in this case, alpha would have an opposite of 1 and an adjacent of 1, which would make a hypotenuse of root 2. In this case, cos alpha would be 1 over root 2. For tan 2, it would have an opposite of 2, adjacent of 1, a hypotenuse of root 5. So in this case, cos alpha would be 1 over root 5. Just basically do both values. First value is 10 over 7 over 1 root 2. The second value would be 10 over 7 over 1 over root 5. And both answers turn out to be, one of them is 2.02. And the other answer is 3.19. 3.19 is the high arcing one where it hits it on the way down, while the shorter time is the blue one where it hits it on the way up. Right, any questions? Who got that? 3.19 and 2.02. On to you. Ah, 22. Alright. Next one. Should have time to finish this one. Alright. Out of interest, was question 4 somewhat harder than question 3? I thought they were somewhat similar in level. But question 4, just the one we'll be doing on next week, seemed to just nobody liked it. Did anybody get full marks in question 4? 50? Anybody got over 40 in question 4? So only one person got over. You got over 40 in question 4? So yeah, so only 2 people got over 40 in question 4. How many people got over 40 in question 3? Over 40 in question 3. Yeah, so 2 or 3 times the amount. Alright, fair enough. Something to think about. A particle is projected up inclined plane from point 0 initial speed of 35 meters per second. The line of projection makes angle theta with the inclined plane. So, you've seen me make mistakes here right away. Always read this part twice. Okay? It says it makes the angle theta to the inclined plane. So that means theta is here. Okay? And theta is that way, then it goes up and it drops down. Happy days. And the angle itself is 45 degrees. Alright. Let's do our gravity triangle, which you're very, very familiar with these days. Gravity triangle going this way. So. Yeah, G. What angle is this here? 45. That's G over root 2. Or G cos 45. And G sine 45 are both G over root 2's. Okay. Now, next thing. Is there any other hints? There we go. Particle is moving horizontally when it strikes the plane. So I'm just going to adjust the look of this question. Down here. It's theta. What does it mean it's moving horizontally when it strikes the plane? What's that mean? Huh? Not theta. The Landon angle. It's an alternate angle. So what you're doing is you're sort of looking for a Z. That's what I mean by Z is something like this. Two interior angles are the same. So what you're thinking is that if it goes straight across, it's not equal to theta, but it's actually equal to 45. So your Landon angle will be 45 degrees if it hits it horizontally. And many people got that idea straight away. Your Landon angle will be 45. Yeah. If you didn't get that, you're more or less out of the ball game, and we're looking for what tap marks I can give you. Okay. So, what we're going to do next is to find the Landon angle. What's the formula for Landon angle? Tan of the Landon angle equals what? Minus Vy over Vx at time of flight. You're going to need the time of flight, you're going to need the Vy, you're going to need the Vx. So that's where we begin. Okay, so let's go through all our equations. Now, we're going to go through this part here as well. Does it give me a speed? Just give me 35 theta. So this is going to be 35 cos theta and 35 sine theta. Now I've got to make my 4 equations really quickly. Okay, so Vx is 35 cos theta. What deceleration, Killian? For the Vx equation, is it the yellow one or the blue one that decelerates Vx?
Yellow.
Yeah, they're both the same anyway, aren't they? But for argument's sake, it is the yellow one. G over root 2 times T. And Vx, Killian?
35 sine theta minus G over root 2t.
Yeah, 45 is a beautiful angle because you don't get it wrong even when you get it mixed up. I don't like it when it comes up in Leavensart and it's 45 degrees. I actually don't like it. It means people get jammy. Right? I don't like it. I love when it's like 30 degrees or something like that. Now, Sx equals 35t cos theta. Half of that is going to be 1 over 2 root 2 gt squared. And then Sy equals 35t sine theta minus 1 over 2 root 2 gt squared. For some of you who can't do these equations yet, you really need to work on that if you're to have any help with doing any of the questions, okay? You're making mistakes there right away. Next thing, we need the time of flight. What's the way of getting the time of flight?
You get a.
So this point here, this red point here, what's guaranteed about the time of flight? Is it Sx equals 0 or Sy equals 0?
Sx.
Now Sx will be this direction here, which obviously has distance. Sy is how far you're above the plane. So if I'm up here, let's say I'm in the air, that'll be like Sy equals 20. But you can see that I'm not actually above the plane when I land. This means Sy equals 0. Because if you're not above the plane, your Sy is 0. Okay, so we're going to start with Sy equals 0, which is this one here. Now we're going to have to solve this. So you're going to get 35t sine theta equals 1 over 2 root 2 gt squared. Cancel the t's. And then, what's that? 70 root 2 sine theta over g. Okay. What do I do with this now? What's the whole point again? I'll write it again on the board. Tan L, which we know is 45 degrees, equals minus Vy over Vx at time of flight. So what 2 equations do I need to borrow from up here? These 2 guys here are coming with me. Size, but you get the gist. They're coming down here. And they're going to come with me to do this part of the question. Okay. Next part. Insert it into Vx and Vy. Okay. So we're going to get 35 cos theta minus g over root 2 times 70 root 2 sine theta over g. Now, what's the deal with Vx? Does it have to be positive or negative, or can it be both? Does anybody know the answer to that? Huh? No, only Vy has to be negative. Why is that only that Vy has to be negative? Think about it. There's the black dot here. You throw it. Phi x and phi y are currently positive. Now phi y is negative and phi x is still positive. Now when it hits the ground, phi y is definitely negative and phi x most of the time is positive. There is the weird one where you sort of throw it high enough, and it sort of does that, and relative to the axis, phi x is negative, but that's ridiculous. I've never seen an example like that, so I wouldn't worry too much about it. So what's our phi x value? 35 cos theta. Then what's it? Minus 70 sine theta. Okay. Phi y is the one where everything has to be. Phi y is the one where everything has to be a bit more. Everything has to be negative. Okay. So let's do Vy. Oh god. Vy equals 35 sine theta. And if I'm being really lazy, what can I say, lads? If I was to be extremely lazy or smart, whichever way you want to look at it, what do we know about the two tails of both of these equations? They're the same, so what can I do? Makes sense, doesn't it? So I'm just being efficient here. And we knew that it had to be guaranteed negative. Okay. Finally, we get to use our tan 45 equals minus phi x over phi y. So tan 45 is 1. 1 equals minus phi y over phi x. So phi y is 35 sine theta. Phi x is 35 cos theta minus 70 sine theta. Cross multiply up, and what do we get? 35 cos theta minus 70 sine theta equals 35 sine theta. 35 cos theta equals 105 sine theta. Who got this one out? Alright, bad, not bad. Alright, then we have sine theta over cos theta equals 35 over 105. Tan theta equals 1/3. So please remember, when you did this